Okay. Ladies. Ladies. Edward. Christian. Jessica. Okay. Put the dice away. This is not D&D. I'm not asking you to roll for damage. Put it away.
Wait, it's 18? The day 18?
What?
The day 18?
Today's the 18th, yeah. Alright. We are going to start moving away from graphs. And we are not... Look at your face. We're going to start moving away from graphs and start moving to actual functions. Okay? Actual functions. Edward, do I have to have you come sit like right in front of me? Shh. Calculus doesn't just deal with graphs. We deal with functions. So today is our first day actually looking at the function and having to find the limit from it. Okay? I'm going to give some definitions. I'm not going to give a lot of definitions. But if you don't remember what a specific part of what I'm talking about is, please stop me, and I will explain it. Okay? So like if I say exponent and you don't know what an exponent is, I will cry, but I will tell you what it is. All right, let's get started. Okay, so today is the 18th, and I'll make sure from this point on, somebody asked me to, when I'm giving you examples or notes, I'll put the level of what it is, okay? So like Monday, thanks. Monday, I put level 1 and level 2, right? Today is going to be level 3, and I'm going to try to remember to do that from this point on, okay? So today is the 18th, and we're going to be working with limits to infinity, involving polynomials and rational functions. Next. Okay. As I said, calculus has to do with functions. And we're going to be talking about lots of types of functions. Regular functions that you're used to, like 3x squared. Do I need to take those away from you? 3x squared minus 2x plus 1. But we're also going to be dealing with rational functions. Give me the dice. Just give me the dice until the end of class. Please and thank you. Please and thank you. Thank you so much. Okay. We know what a polynomial is? It's just a regular equation. Okay? Do we know what a rational function is? No? Okay. Then let's give that definition. A rational function. I'm going to put it in a simple term because I don't want to go too formally into this, but a rational function is just a function as a fraction with polynomials in the numerator and denominator. Do you want an example? Yes? No? Maybe? Okay. So for example, if I have f of x, And I have 2x cubed minus 7x plus 3 over 9x to the 4th minus 5. This is a rational function because I have a polynomial in the numerator and a polynomial in the denominator. Can you see this color or no? No? Okay, sorry. Now?
That says 7 times 13.
No? No? That's plus. Plus 3. Okay. Better? So don't use this color anymore? Is this color better?
Yeah.
Okay. So that's a rational function. Has a polynomial in the numerator, polynomial in the denominator. Okay? When we talk about rational functions, we have specific rules on how to find the limits or polynomials. Okay? We have rules on how to find the limits. So, I'm going to do the rules in words and then do the rules in notations. So, in words, limit to infinity and beyond. Rules. Oh my. Okay. So I'm going to do words first and then we'll do notation. What? If the degree in both the numerator, is it okay if I abbreviate numerator and denominator? Denominator are equal. The limit is the ratio, and I'll stop in a second, of the leading coefficients. Because I want to ask some questions. Is that better? Okay. A couple things. Do we know what a ratio is? Can somebody tell me what a ratio is? You can't talk. I don't want you to lose your voice. It's okay if we don't know. I saw one person shake their head. A ratio is just a fraction. That's all it is. Okay? Ratio is a fraction. Do we know what a leading coefficient is? No. Okay, I'm going to abbreviate leading coefficient, okay? Leading coefficient. A leading coefficient is the number in front of the term with the greatest exponent. Do we want an example? Okay, somebody said yes. I'll just do a quick example. Don't judge. At least they're trying to learn. So let's say I have 9x. Can you see that color? No? I gotta get new markers. 9x to the 4th minus 15x to the 5th plus 7x to the 9th. What is No? What's wrong? What is the highest exponent? 9. So then what is the leading coefficient? 7. So this is the highest exponent, and this is the leading coefficient. Oops, I put leading coefficient. Okay? Okay, so we get leading coefficient and we get ratio. Yes? Okay, so now let me go back to the rule. All right? So I know you're probably like, that's a lot of words, I don't get it. Well, you get it hopefully when we do an example. But what you need to know about this is if, basically, if the degree is equal, the limit is the ratio. That's all you need to remember. But guess what? What do I let you do? Use notes, okay? So write. Mia, where do you need me to zoom? This side? Good? Okay. So that's the first rule, okay? We're gonna have a rational function. If you wanna flip over or look at the sheet, you'll see what I mean, that I passed out, you'll see what I mean by what it looks like, okay? Can I move this rule? Everybody have the rule? Okay, let's look at the second rule. The second rule says, oh, I guess I should have numbered it. We'll number this one. Do you want me to put it back? Oh. Second rule says, if the degree of the numerator is greater than the degree of the denominator, then the limit does not exist. Who's out? Mama. Okay, so what's important on this one? If the degree is greater, of the numerator is greater, the limit does not exist. Do we want an example on that, of what I'm talking about? Okay, sorry. Do you want me to go back and give you an example of the other one too? All right. Let me, okay. So, sorry. Let's do an example for this one. So let's say I have 10x to the 4th plus 7x to the 5th minus 16x squared over 4x cubed plus 7x to the 5th. Okay? What is the degree in the numerator and the degree in the denominator? So remember, the degree is the highest one. What is the degree? The highest exponent. Degree is exponent. 5. Okay? Now, because they're equal, I take the ratio, which means I'm going to take these two things and put them in a fraction. Okay? So then the limit will be 7 over 7, which is 1. Okay? Now that there's an example, do we kind of see where I'm coming from? Okay. Sorry about that. Good? Can I go back? No? Somebody say no? Somebody say no. we ready now or no?
Yes.
Okay, thanks. Okay, so let's look at this one now. So if we have f of x, oops, sorry, that's not supposed to be there. I almost asked myself why I had dice in my pocket. Don't put this underline. I can't find my whiteout. F of x is equal to 10x to the 4th plus 7x to the 5th minus 16x squared over 4x cubed minus 3. Okay? What is the degree in the numerator? The highest. So when I'm talking about degree, I'm looking for the highest exponent. 5. It's not always going to be the first one. It will not always be the first one, okay? What is the degree of the denominator? 3. Okay? So now, because 5 is greater than 3, the limit doesn't exist. Okay? So far, so good? All right. I'm assuming it helps with the examples? Okay. I apologize. Can I go down, though? All right. Last one in words, and then we'll do notation. If the degree of the numerator is less than the degree of the denominator, oh, I cannot spell. The limit is, what do we think? Do you have no thoughts? Throw something out there. We have a number, we have does not exist. Anything? Any thoughts? Bueller? Nope, we have does not exist already. We have a number already. 3. No. It's 0. 0. Yes, 0 is a number, but it's not specific enough. So, 10. Numerator is less. The limit is 0. I'm assuming we want an example on that one? Thanks. All right. What is the degree of the numerator? 5. What's the degree of the denominator? 10. So because, yes. So the limit is equal to 0. Okay. We've got the notation to do. That should go quick just because we kind of understand with these examples. But the notation is what you're going to use, and this vocabulary is what you're going to use to provide rationale for answers, okay? Can I go or no?
Yeah.
Yes, okay. All right, notation. I'm going to go a little quicker for this one, but stop me if you don't understand what I'm doing, okay? All right, notation. For limits as x approaches positive or negative infinity of f of x, okay? All right. So if we have f of x is equal to ax to the m over a, nope, not a, put b, bx to the n. So these are going to be polynomials. Man, I cannot spell today. Polynomials. Sorry. And then m and n are the degree. What is the degree? Anybody remember? Exponent? But what specific exponent? The highest. A and B are leading coefficients. Can I go right there? Yes? No? Okay. Okay, I'll wait until everybody's done so I can give the notations. We've got 3 notations, then we get to examples, okay? 3 notations and then examples. 3 notations and then examples. Yeah. Oh, I can't use that color anymore. Why am I using it? Okay, ready? Okay, first notation is if m is equal to n, then the limit as x approaches positive or negative infinity of f of x is a, not, I am so discombobulated today, I'm sorry. A over b. So if m is equal to n, then the limit is a over b. Can I go down right there? No? Okay. 2. If m is greater than n, then the limit as x approaches positive or negative infinity of f of x is what? Does not exist. And then last but not least, if m is less than n, then the limit as x approaches positive or negative infinity of f of x is equal to 0. All right. When you are done writing that down, take out this printout that I passed out. We have about 15 minutes, less than 15 minutes, for me to go over the examples. The back will be your due now tomorrow, okay? So don't lose this. He hasn't come back. You're right. Let me do these examples. If we have time, you can go. Okay, I don't want you to miss the examples. Ready? All right, let's go. Let's look at the first one. First thing you always want to do is you want to find. First thing you always want to do is you want to find the degrees. The degree of m and the degree of n. What is the degree of m? Remember, it's the highest what? It's the highest exponent, and Xavier said 2. That is correct. What is the degree of n? 0. There is no denominator, so it's 0. Look at that. Okay? First thing, find m and n. Second thing you want to do is you want to compare them. Okay? M is what to n? Greater than, less than, equal to?
Greater than.
Greater than. That's what I mean by compare. Okay? Okay? So, if m is greater than n, what is the limit? Does not exist. Where are you getting that from? What rule?
Second.
The second rule. Okay? Ooh, is that 2 zoomed in? My bad. That makes sense?
Yeah.
Are we sure?
Yeah.
Okay. No? Do you say no? Next one. What's m? What's n? M is, I heard 7. That is correct. What's n? 7. That is correct. Am I going too fast? You sure? A little bit? Okay. M is what to n? Equals. Edward, go quickly. Quickly. Or not. Or you can just stay in class. Okay, so if m is equal to n, what does that mean? What's the limit? No, and that is where students get confused. It's not 7 over 7. No. Now we need to find A and B. What's A? What kind of 10? Negative 10. Remember, A is going to be the number that's in front of the exponent, and B will also be in front of the exponent. So we have negative 10 over negative 5. That gives me positive 2. Okay? Are there any questions on how I did that one? Are we sure? Some of us are still writing, that's fine. Some of us have moved on to number 3, that's fine. If you're still writing, can you just let me know? I'll give this to you in a second, Brian, okay? I'll give this to you in a second. Do you need these though? You need these though, right? All of them? All 3?
All just one and two.
I don't know which page that is. Okay, ready for the next one? All right, no, too bad. That is the limit, yes, but why? What's m? What's n? Okay, n is 3, but m is not 0. It's 1. It's 1. Remember, if there is an x and there is no exponent, the understood exponent is 1. If there is an x and there's no exponent, the understood exponent is 1. Okay? So m is what to n? M is less than n. So the limit as x approaches negative infinity is equal to 0. Questions? We sure? Okay.
We already gonna write that 0 next to it.
No, that's just for you guys to know that it's a 0 and not an O, or like does not exist. Okay? Alright, last one. What's m? What's n?
6 and 3.
6 and 3. M is what to n? So the limit is,
Doesn't
does not exist. Man, Xavier is on a roll. Good job. Do you want a sticker?
No.
You sure? I've got good stickers. I've got math stickers and I've got Dave the Dead stickers. I don't have chips. Sorry. Do you want a stamp? All right, we have 6 minutes. Are there any questions? You can start the back so that you have less to do for your do now.